Okay, it's me, Alexander again, and today we'll focus on two typical thermodynamics problems. So we'll start. The air above a large lake is at -2 degrees Celsius, whilst the water of the lake is at 0 degrees. Well, this is the water, so when it turns into ice, some latent heat will be transferred to the surroundings. Assuming that only thermal conduction is important and using relevant data selected from the given below, estimate how long it would take for a layer of ice 10 centimeters thick to form on the lake's surface. So there are three types of heat transmission: thermal conduction, thermal radiation, and for the air we have 热对流, right? And for this question, we will choose area A of the lake, and we'll figure out what will happen if we already have x centimeters of ice, and we're going to generate delta x centimeters of ice. So how long would that take? The latent heat needed for this would be Li times actually it's dm, but right, dm, but this dm equals A times dx, right? So this should equals to the heat transferred out, and that is according to Newton's heat formula. It is lambda I A times delta T over X. So this wait a minute, we have a row here. This is the thermal conductivity of ice. We have the cross-sectional area, and this is the temperature gradient. We time them together to get this equation, and we're going to figure out T equals yes, 1/2 times x squared times rho I Li over lambda I delta T. Delta is to temperature 2 Celsius, and plugging in the data we get T is approximately equals to 90 hours. The second question is some Feynman question, right? So if it takes 2 days to defrost a frozen 5 kilograms turkey, estimate how long it would take to defrost an 8-ton Siberian mammoth. So we don't have one data to extinguish from the turkey and Siberia, so we're going to figure out the scale, right? So let's think about the time taken to defrost. First of all, it must be inversely proportional to the area, right? The area that will conduct thermal energy to the air, so area. Also, we have the temperature gradient, right? The temperature gradient would be the center. We have T0, and there we have T air, and the gradient equals to T0 minus T air over this side. It is approximately half of the length of the this animal. If we can just see it as a sphere, right? So times length, and here we have the total energy for the latent heat, and it is proportional to volume and we can multiply them together. We have L to the L cube over L squared L to the minus 1. So here we are going to apply this. So time is proportional to the square of the size, and also we have m. The math is proportional to L cube, so time is proportional to m 2/3. Now plugging these data in, and we get t is over about 9 months. What is interesting that in Siberian there are no 9 months of summer, so the mammoth cannot be defrosted anytime. And that is all for today, and I'll be glad to see you next time. I'll be doing more interesting physics problems, a certain Cambridge interview with Natural Sciences Physical, and happy for your listening.